right? Next step is to run OLS regression. In this case, I use OLS regression as an example. You can apply the same logic in other types of regression analysis. So in this case, what I'm going to do is I want to run a regression of this continuous variable, mental health. So in this case, number of days not feeling very well in mental health. So the, in the past 30 days. So the values of this MNTL, HLTL, mental health, stands for mental health, right? Ranges from 0 to 30, okay? Corresponding to, well, a label of having 0 day of poor mental health issues to 30 days. So roughly we can treat this variable as a continuous variable, okay? And later on we'll learn that this is actually a count variable, but we won't bother that until we hit count regression. So this is the response variable, and roughly we can treat it as a continuous variable. And here I have two independent variables or covariates, right? Age and female, right? This dummy variable for sex. So we can run this regression, okay? So use data and we can summary the regression. Okay, perfect. So let's look at the results. Let's look at the results, okay? So here we have, residuals, right? And coefficients, right? We don't have to get into all the details about residuals, but let's focus on this panel, right? Coefficients. And we have the coefficient for intercept, we have the coefficient for age, and we have the coefficient for female. So the question here is how to interpret this coefficient for female. And we know that for this dummy variable, female, that's a dummy coding for sex, right? Sex, because originally it's coded as 1 and 2, and we cannot use a dummy coded as 1 and 2. In most cases, we cannot, okay, in a regression analysis, because otherwise, it's going to mean that females, which is coded as 2, is double, okay, in value, okay, of male, because male is coded as 1, and there's no numerical or substantive meaning of that doubling, right? So we have to turn it into 1 and 0. In this case, okay, when we use female, male is coded as 0 and female is coded as 1, right? So always in this case, okay, we're gonna use the category, the group that's coded as 1, compare with the category that's coded as 0 and omit it in the regression, right? So in this case, what we're going to say is holding all other variables constant. So what are all other variables? Well, here, age, right? And then we're going to say on average, females have what? Additional 0.90082 day of feeling mental health problems, okay? So additional days, okay? Then males have, So we're comparing the number of days having mental health, okay? Between females and males. And male is the reference category, or is the group that's compared to, right? Well, people say, well, here we only use female. What about, having all, dummy variables? Because we have 2 dummy variables, right? One is, for females being coded as 1. Another is for males, okay, to be coded as 1. Can we use both? Yeah, well, we can run this regression and see what's going to happen. So I highlight these 2 lines and run the regression. Do you see that? Well, the line for male is dropped. Okay. Why? The question is why? Okay. Mathematically speaking, if we create k dummy variables, okay, and each for each value category in that multi-category variable. Okay, let's say k for k. We have to drop 1 in our regression analysis. Why? Because automatically we estimate intercept. Okay, then male, then female. If we don't drop 1, then the intercept along with the full set of dummy variables going to create what is called perfect linear dependency, which is going to make the system collapse. And that's exactly what happened. And that is reason why our LM function automatically drops the male variable here. Okay, and people say, well, why male was dropped? How about female? Okay, well, basically, it's gonna drop the second one when the LM function finds there's a problem. Because it hits intercept, it hits female first, right? In our previous regression. When it hits male, it knows there's something wrong, mathematically speaking. So let me switch male and female and see what happens. You see that? In this case, female is dropped. Female is dropped. Okay? So when we make mistakes, it's gonna correct, which is nice. So let's get rid of female and run again. Well, basically, we're gonna get the same set of results, right? So in this case, how to interpret the results, okay? Well, in this case, for this male dummy variable, male is coded as 1 and female is coded as 0. So female now becomes the reference category, becomes the category that's compared to. So in terms of interpretation, because we have a negative sign here, here is what we're gonna say, okay, holding all other variables constant. Here actually is only age, right? We can add a couple more variables. We're going to say holding all other variables constant. Okay, males on average have fewer, have 0.90082 fewer day of feeling issues, problems with their mental health in the past 30 days. Okay, then females do. You see that? So we switch interpretation, right? We say, well, fewer days. But when we compare the results, number of days, they're exactly the same. Here is male having 0.90082 fewer days than females, right? What about females? If we use female, well, for female, it has 0.90082 days, more day than males do. So just reversed interpretation, but substantively speaking, they're equivalent. And how about age variable? Age is negative 0.01223. What about age down below? Same thing here. So mathematically speaking, okay, in this case, for a binary variable, after we created dummy variables and use either one, the results are mathematically equivalent. And